In this video, you'll be able to determine if a data set is a function or not, as well as to determine what the domain and range are of a set of data or a graph or a chart. So let's start by describing what domain and range mean. So we have our x values and our y values. Our x values are called the input sometimes. They're also called the domain. And our y values would then be the outputs and our range. So moving a little bit forward, something is a function if each input has only one output. So let's see what that looks like. So remember, we have our domains, which is our x, and my ranges, which are my y's. We list our domains and ranges in numerical order, going from least to greatest. So if I look at my set of data here, my least would be -2, then -1, then 0, then 1, then 2. So again, I list those in my brackets, -2, -1, 0, 1, and 2. My range is my y values. I have 0, 1, and 2. Now the question you have to ask to determine whether if it's a function or not is, does each input only have one output? So this input of 0 only has one output of 0. The input of 1 has one output of 1. The input of -1 has one output of 1. The input of 2 has one output of 2. The input of -2 has one output of 2. Now even though these inputs share an output, each input only has one arrow coming out of it. So the answer is yes, it's a function. Looking at my next set of data, I have my domains here and my ranges here. Again, I put my domains in numerical order, with being 1 and 4. And my ranges go in numerical order. I have -1, 1, -2, and 2. So if I put those in numerical order, -2, -1, 1, and 2. So let's decide if this is a function or not. So the input of 1 has two outputs. The input of 4 has two outputs. So because this input of 1 has two outputs, that means it's automatically not a function. And also because 4 has two outputs, that is not a function. Now let's look at this next set of data. Again, my domain is my x, and my range is my y. I have x, y, x, y, x, y, x, y. So if I list my domains over here, which would be -2, 3, 1, and 0, and I list my y's, I have 3, -2, I have 3 again, I don't need to repeat that, and I have -2 again, I don't need to repeat that. So let's match those up. -2, if I would draw an arrow, it matches with 3. 3 matches with -2. 1 matches with 3. And 0 matches with -2. So again, my domain, I have to list these in from least to greatest. I have -2, 0, 1, and 3. And my range is my y's, least to greatest, -2, and 3. Again, I don't need to repeat them, even though I have 2 of each. So because each input only has one arrow coming out of it, that means it is a function. In my next set of data, again, domains are x, ranges are y's. So I have x, y, x, y, x, y, x, y. So let's list my domains and ranges here. So I have 3, -2. Again, I have a 3 already, and I already have a -2. So let's list my ranges. I have -2, 3, 1, and 0 for my y values. So let's go ahead and match those up. 3 matches with -2. negative 2 matches with 3, 3 also matches with 1, and negative 2 also matches with 0. So again, my domains are my x's. I list those in from least to greatest, negative 2 and 3. And my ranges, again, from least to greatest would be negative 2, 0, 1, and 3. Now, because each of these inputs has 2 outputs, the answer is no, that is not a function. In the next example, I'm given a chart here. My domains are my x's, again in numerical order from least to greatest, 1, 3, 5, and 7, separated by commas. And my ranges, negative 1, 4, and 6 are already from least to greatest. So the question is whether if it's a function or not. Each input only has one output, only has one arrow coming out of it, so that is a yes. And in my next one, my domain x's and y's, again I have to go from least to greatest, so that would be 0, 1, and 3 separated by commas. My range in least to greatest would be negative 2, negative 1, and 0. So if I look to see if this is a function or not, this input has one output, this input has one output. However, 0 has 2 outputs, which means that is not a fraction, or not a function, because it has 2 arrows coming out of it. Alright. On the back, the vertical line test says if you make a vertical line and it only goes through or only crosses the graph once, then the graph represents a function. So what does that mean? Again, we're using a vertical line. So we're going to draw a vertical line through this line right here, and to see how many times it intersects this line right here. So if I were to draw a vertical line right here, it looks like it intersects it once. Let's do a couple more test lines here. If I were to draw this vertical line right here, it only intersects my line once. If I were to draw this vertical line here, it only intersects the line once. So no matter where I draw my vertical line going through, it only intersects my graph one time, which means it is a function. In example 2, we have an upside down parabola. If I were to draw my line through here, it only intersects my graph once. If I were to draw a vertical line here, it only intersects my graph once. And if I were to draw a vertical line here, it only intersects my graph once. Which tells me, again, if my vertical line only intersects my graph once, it is a function. In example 3, if I draw a vertical line here through my graph, it intersects my graph twice. If I draw a vertical line through the graph here, it again intersects my graph twice. And if I were to draw a vertical line here, it intersects my graph twice again. So because it intersects my graph more than once, it is not a function.